Hello everyone, today I will be discussing about Scilab, what Scilab is and how we do calculations in Scilab, numerical analysis questions and all. So Scilab is a programming language in which we solve numerical analysis questions like secant method, bisection method, regular Falsy method and so many methods we have in numerical analysis. So when we do it with manually, then we use scientific calculator and we do calculations. But when we have to do calculations, like we do calculations for number of iterations. So when we have to do iterations like 10 times, 15 times, then it gets more lengthy and complicated. And we have to do calculations that many times, like 10 times, 15 times for 15 iterations. But here in Scilab, what we can do is we can write the code and easily just write the number, like how many iterations we want. We will write 10. It means we want 10 iterations. And the Scilab will give you the output after the code is written. So we will be starting with our basic intro of Scilab and basic from beginning we will be starting. So this is the Scilab console page. So all these things we'll be discussing later on, like what is the use of these things and all. So we'll be discussing during the videos only. So we'll be starting with the basic Scilab calculator. So Scilab works as a basic calculator. So it will write 2 plus 4. So it gives like this 4 minus 2. Then this is the answer 6 divided by 4. So this is a float number. And 4 divided by 2. This is integer. When we will write modulo. So modulo, if we write 3 and 5. So it means when we divide the number 3 by 5, then what is the remainder we get? The remainder we get will be 3 only. But if we will interchange the number 5 and 3, that is if we divide 5 by 3, then the remainder we get is 2. So this is the number we got, and this is the basic calculator, and we can also do the power exponential and all. It is 2 to the power. The answer is 16. 4 to the power 3 is 64. So this is all the things. This is the normal calculator which is inbuilt in Scilab, so we can use these things. Also, we can see here that we are writing the code in a single like 2 plus 4. Then we are getting output. When we press enter, we get output 6. Then after writing 4 minus 2, and we press enter, and then we get output 2. So and these are the inbuilt functions. So what we will do is during the numerical analysis solutions, we will write multiple line codes because one line code cannot help us. So where we will be writing these multiple line codes. So there is a notepad for that. We will be discussing later on. So now we will be starting with arrays. So this is the basic calculator we have. So after this, we will be clearing the console page. This is the then we will click this one. Then we can clear the page console page. Console page is cleared now. Now we will be discussing about arrays. So what are arrays? Then we will write A is equals to square bracket 2, 4, 5, 6. And we press enter. Then we get these numbers like this. We will do A plus A. So A is got added to itself. 2 is added to 2, 4 is added to 4. 5 is added to 5 and we get 10. 6 is added to 6 and we get 4. So when we will do A minus A, obviously it will be 0. We will do A to the power 2. So each element is raised to the power 4, 2 to the power 2, 4 to the power 2, 5 to the power 2, and 6 to the power 2. So this is how these normal operations can be done in arrays. Now our next topic is matrix. How we write matrix in Scilab. So I'll write M1 is our matrix 1. We'll do this. So matrix is what? This is our array 2, 4, 5, 6. So we want another row. This is one row. We want another row. We want another row, and this is how we form a matrix. So one row we can form by this. So how we get another row? So we'll write like this. This is 1, 2, 3, 4. So this is the first line. So we want the next line. We now want the next row, so we will give semicolon and then we will write the another thing. 2, 4, 6, 8. Then we give semicolon, so we'll get next row. So we'll get 5, 2, 3, 4, any output and entry and writing, we'll enter. So see, we got this 1, 2, 3, 4, 2, 4, 6, 8, 5, 2, 3, 4. This is the 3 cross 4 matrix. So how we will know that this is a 3 cross 4 matrix? 3 cross 4 means we have 3 rows and 4 columns. So these are the rows and these vertical lines are the columns. So we have 4 columns and 3 rows. This is the 3 cross 4 matrix. But here we can get by writing size of M1. We write size of M1 and then we can see that 3, 4 means 3 cross 4 matrix it is. So this is how we write matrix in Scilab. So this is the matrix matrix entries, and next thing is we do matrix operations and also how we do same like arrays we do. And next thing is okay, I'll write another matrix M2. which is yes 1 0 0 then 0 1 0 then 0 0 1. So this is if you know this one, this is the identity matrix, 3 cross 3 identity matrix. So we can there is a shortcut for writing this one. There is a inbuilt function. So this is if we write I, which is identity matrix, EYE 3 comma 3. When we write I 3 3, it means we will be Scilab will directly give you the 3 cross 3 identity matrix. So this is the method to write identity matrix. You will write EYE 5 comma 5. It's the 5 cross 5 identity matrix. Now again I'll clear the console page because we're doing so many things here. Starting from arrays and then matrix M1, size of matrix, identity matrix. So we'll clear the console page and we'll move to the another thing is random matrix. So R is the random matrix. So how we write random matrix is RAND 4 comma 5. It means it will generate a 4 rows 5 columns matrix and it will give the random entries in the matrix. This is how we generate random matrix. Now we will know how to find the determinant, rank, inverse and all those things. So let's take our matrix M2. We given the matrix M2 as identity entry. So if we'll have to find the determinant of this, we will write det M2. It's determinant of matrix. Determinant is 1. Again we'll find rank of M2. Rank is 3 because we have 3 rows which are linearly independent. So this is a rank. If we want to find the inverse of the matrix, then inverse of M2 is identity. The inverse is identity only. So the inverse of identity. So we took the matrix M1, this one. Since this is not a square matrix, so we will not be able to find determinant and inverse, but we'll be able to find the rank. So let's find the rank of this one. Rank of M1 is, so this is 2. So when we'll do the row operations and all, and then you will find this, you will get the rank is 2. But from Scilab, we can easily get in one line that how within seconds that what is the rank of the matrix. But we will not be able to find the determinant and inverse of the matrix since the matrix is not square. So I'll enter a square matrix. So here the console page. So this is S. S is square matrix. So I'll write 2, 4, 3, 3, 1, 1, 3, 2, 5. So this is a 3 cross 3 matrix. We'll write size of S is 3 cross 3. So this is 2, 4, 3, 3, 1, 1 and 3, 2, 5. So this one is first line, then after semicolon is second line, after semicolon is third line. Now I'll write determinant of S. Determinant of S is minus 33. We can easily get the answer in a very short period of time. Inverse of S is, since determinant is not 0, the inverse exists, and we can get the inverse also. Rank of S is 3. So these things are determinant, inverse, ranks are can be calculated easily. So next thing is what are the operations and next thing is the trace. Trace, what is the trace? Trace is the sum of diagonal elements. This is 2, 1, 5. The diagonal entries are 2, 1 and 5. So if I write trace S, then this is 8. So 5 plus 1, 6 and 2, 8. So this is the trace. Trace means the sum of diagonal entries. So we written M2 as this one, 1 0 0 0 1 0 0 0 1. So what is the trace of M2 is 3. The sum of diagonal entries are 3. So these all are the matrix operations.